Welcome to the Chapter 5 lecture on lists. Now, probably in your C++ or your Java classes, you talked about linked lists. So we're going to kind of go through this relatively quickly, but maybe give you a little bit, a few different algorithms to do certain things with a list, and then look at different types of linked lists, AA linked lists, circular linked lists, just to show you what they are. But the concepts are the same as far as to insert, delete elements in those structures. So hopefully we can go through this relatively quickly and you'll actually get something out of it. So we're going to look at the basic operations of a linked list. How do I insert, how to delete, how do I retrieve things, and how do I traverse, how do I move along to find information inside a linked list. So just to give you graphically what we're looking for is I've got a list. As far as this is for insertion, so I've got a list existing. I want to insert the number 25 into it. I call my insertion routine, and my result is somewhere in this list in the sequence, because we're still trying to keep things in a sequenced order. If it was a random list, I didn't need to worry about the order, what would I do? I just plop it at the end and be done with it. But that's usually not the case with most linked lists, is you want it in a certain sequence, so that speeds up your operation in processing the data. So in this case, we're inserting data, so I've got to traverse, find where these two match. So what I've got to do, I got to do some kind of comparison between items, insert the data, and go through. If I'm going to delete it, here I got my existing list. I want to take red out of it. What do I have to do? I have to find that identified delete item, delete it, remove it, make modifications of the structure, and go through. If I'm just retrieving, as we did with our stacks and queues, there are some functions I want to find an item, but I don't want to actually get it out of my lists. So I'm just retrieving the value, and my list still stays intact. Same thing with stacks and queues, where he says I just want to find an item, don't remove it from the stack, don't remove it from the queue. So we've got the same thing in a retrieval. And then if I look at the concept of what does it look like, yeah, we've got a list that graphically is some kind of list of numbers. But what do we see in our programs? Well, we've got some kind of head node along with data nodes underneath, so with each one having data and a pointer to the next item in the list. So this is kind of the concept, and you've seen it when we did queues and stacks. So we're just kind of generalizing this as far as any types of other applications you may want to do. So basically you've seen this type of a structure before. You've got a head structure which has a count and some information in it. And you've got each data node has some group of data, which could be a structure of data, and then a link to the next items. So this stuff hasn't changed as far as what we've seen in stacks and queues. Now, what do we have to do? We had to create the list. Remember, we had to create a stack, create a queue. Same thing happens for the list. I've got to allocate the memory, zero out the count, nullify the head node because there is no data attached to it. So that create function is pretty much the same. And if you get into the algorithm, it looks identical to the ones we've seen as far as stacks and queues, except the name changes. Now, inserting. Now, there's several different options, or I shouldn't say options, they're conditions or situations as far as inserting. I can insert at the beginning. What happens if I have an empty list? What I have to do? Well, I've got where'd my pointer go? There it goes. You've got your head node, which has what? A zero count and a null pointer. And I've got a new bit of information I need to add. Now, the first thing I want to do is I've got to change this pointer to null because because I'm not going anywhere. So it's my first item. It's the head of the list. So I'm going to take this pointer, nullify it, and then I'm going to change the address of the head to point to the address of this new. So basically, I'm nullifying the new address of the pointer, and I'm setting the start of the head list to this new item. So if I had a node that actually wasn't empty, so this one says empty list, I got a null pointer here. Oops, wrong way. What happens if I want to insert? I've got one item in my list, and I want to add the node at the beginning. Basically, the same thing happens is I've got to nullify this pointer, right? So I've got to point, actually doing a couple of things. One is I've got to change this pointer. I'm not nullifying this because I'm inserting in the beginning. My mistake is I've got to I've got to take this address and point it to head. So I've got to copy the head pointer to this, because when it was the previous one, when there was no nulls, what we do? First thing we did was we nullified this. Well, the first thing I'm doing is I'm changing the pointer to match the head. So now I want to point, the data 39 to 75, and then I'm going to change the location of the head pointer to the address of new. Now this sequence is very important, because if you changed the head location first and then try to point to the next item, once I copy that list over, I may lose all the data in the chain. So you got to be careful. So you want to make sure you point to, change the new item, point to the list, and then change the location of where you're starting your list from. Now, if I'm doing in the middle of something, what am I doing now? Granted, there's a seek operation that you're trying to keep in mind, so we haven't talked about traversing that yet, but it basically, the sequence is the same. So just making sure that your head node never changes, but now my previous node, here's my previous, here's my new one. So I got to change the link to the previous, point it to the new one, and then change the address here as far as pointing to, in this case, the number 75. So it's just paying attention to where you're trying to insert, and of course if you do it at the end, that's one is relatively easy. Again, what am I doing? I'm changing an address here, nullifying this one. But just make sure you do it in the correct sequence. So here's this algorithm all intact, taking all of these conditions under consideration. So allocate the new item you want to add. Assign the data to that new item. If this pre is a pointer to the data's logical predecessor, you want to double check. Am I adding it to the first node or an empty list? Then go ahead and do what we were doing before. Otherwise, it's somewhere in the middle or at the end, and then you're setting the links up. And then basically return true if it's successful. If for some reason it fails, you want to return false. Now, why would it return false? If you got a memory overflow. So insertion, it's just like I said, paying attention to the conditions as far as it's an emptier node or I'm doing a middle at the end. Now deletion. Now, again, you got a couple of different options to deleting the first node. So what am I doing? If I'm deleting number 39 here, I've got to make sure that I've moved the head node. I've copied the head node to where? To this previous node. I've got to set the head node to that next location. before I remove it. And then once I do it, then I can recycle that. But don't clear this before you've moved that pointer to the next item. Otherwise, what have you lost? I've lost the entire structure. So in a general case, you want to make sure you set the item, set your address to the next item. So if I'm going to, whatever one I'm deleting, the location I'm deleting, whichever one I found I'm deleting, I'm going to move the pointer past it and then remove it. So our algorithm for this is, I'm double checking if this pointer to the pre is the pointer of the predecessor. Is that predecessor null? I'm deleting the first one. If it's not, I'm deleting other ones. Now I'm setting the predecessor to the location of that new location, and then the one I'm getting rid of, and then go ahead and remove it. Whoops, made that one a little. So just some rough idea as far as when you're listing things, as far as what conditions, and if based on previous and location, what you're trying to insert, and what kind of returns you'd be. I'll have to edit that PowerPoint slide. Now, what happens if I'm searching a list? So this is an ordered search because you got ordered list. So that means you can expect numbers to go in some sequence, whether they're smaller to greater, greater to smaller, some sequence. And you got to make sure that if certain conditions are true and certain conditions are false. If for some reason, what would make a system, if I'm looking for the first item, that would be, yep, I could say, yep, I found it. Found it in the middle. That's okay. Now, it's when I start getting into looking for numbers less than a target or greater than a target. Give me a number that's less than 5. Well, in this case, there is no value less than 5, so I would return a false. Here, if it's greater than 15 or less than 20. Now, you look at these and, well, it is 15 and 20. Pay attention to it isn't greater than or equal, it is greater than. So you got to make sure that you're paying attention to what you're checking. So algorithm here for searching the list, you've got the precondition, you've got your list, you've got your predecessor, you've got your location of the current node you want to do something with. The target is the key being searched, so that's the one you're looking for. And then you want to return the value once you find it. So let's go. So you make sure you set location to the first null. My predecessor set it to null. And now I'm going to loop through looking at all of this, comparing everything to the target, and then go ahead and modifying my routine. If it's found, it's not found. So let you go through that algorithm. It's not too complicated, but you're finding the location and then deciding what you're going to do with it, whether you found it or haven't found it, setting it back to true or false. Because this is a search. This isn't a delete. This isn't an insert. I'm just searching to say, did I find it? Or did I go all the way to the end and, oops, I went all the way through and that next location's a null. That means my pointer, that means this pointer way out here is null. So I went through the entire list and I got to a null. There was no valid pointer to the next item. So that says, hey, I've reached the end. It's returned false. And go through. Now, what happens if I want to retrieve? Well, guess what? Now, retrieve says what? I got to do two things. I've got to search my list. I'm going to call my search list. So I'm going to go back and call the search list routine to say I'm trying to find the item that I'm looking for. Now, we've got to keep in mind now, you're not deleting things out of this list. So you're not deleting things. You're just saying, hey, I'm going to search my list. Did I find it? Yes or no? And then, of course, I'll take that location and copy it to data out, but I'm still leaving my list intact. Empty list basically says what? I'm going to, delete this list, get rid of it, and basically I'm going to check if my count is 0. If not, I'm just testing, is this thing empty or not? This one, again, testing if the list is full. Now, this one, like we've done in the past, it's difficult to know based on C language and other languages that to know how much have you got enough memory in your system. We've used this count routine before to go through and just, what have I been doing? I'm just going to the head and just printing off whatever the count is. No big deal. Now, if we look at that traversal routine again, this is what it would actually graphically look like. I start with the count, the position, pointer to the head, and I'm going to go through each item there, going through it. So I'm going to use that traversal. So this is kind of the graphic you're looking at. You got your head pointing to several different locations, and you're going to go through each position, verifying that exists. So again, you've got the structure with the valid list, from where it's 0 to the first element to data out. You're going to, from where am I starting, pointer to the list, from where is, in most cases, you're going to say start at the beginning of the list, and then data out is where you're going to store the data. Now, and of course, true or false. So if it's a list empty, there's nothing to traverse. So you're going to say, hey, I'm done. But you're also going to tell them, hey, there was no list to traverse, so I'm going to give you an indicator that something's wrong. Now, if I got to check from where is it the beginning? So am I starting from the first? Then I'm setting my position to the start of the head, and then I'm going to move current list to the top. Now, if it's not in, so I'm going to continue from that position to the end of the list. So get the move the data in. So not too much complicated. Now, destroy list says what? Basically says, hey, I'm going to get rid of this. I'm going to loop all the way to the end, but I'm going to delete the memory as I'm going along. But you got to make sure that you're, not destroying things too quickly. Now, let's look at some ways you can, now, granted, this is where we do a lot of C code, and we're not going to go through how these algorithms are written in C. If you're interested, go ahead and pay attention. But conceptually, this is what we can have. You've got a count, and you notice there are several different pointers based on what we're looking for. And it's good to keep in mind what's the head, what is my current position, what's the rear of the node. Having some of that information up front can make things easier and give you more flexibility in solving problems just by having the right header information. So just to give you a rough idea as how these function. Your user function, in your user program, you got your main, you said, hey, I want to compare two values and whatever else you're trying to do here. But the public functions that you're going to use are basically create, traverse, the ones we just came up with. And then when you start looking at searching, now I'm going to get some private functions where it's based on individual structure that you're processing. So let's look at some different, maybe a little bit more complex linked list applications. Now, one is a circular linked list. And basically that means I've got a pointer to the front of the list and a pointer to the rear of the list. And that one at the rear is going to point to the first element in the list. So that way you've got, where the end is, where the beginning is, and inserting any place else, you just got to remember that if you're doing something with this, the rear, you've got to modify 2 different pointers because I got to change 2 locations. So it's just a matter of you got 2 links because you're trying to keep track of 2 positions. And then as your case is developed, you just got to keep in mind that I'm getting rid of a key element. Inserting the first, inserting the last. Now, again, if I'm inserting the front, you've got 2 pointers to worry about. Making sure I get the rear and the link together. But just knowing that this gives you flexibility to go either direction. Does it say either direction? No. It's still a one-way ticket because all my pointers are downstream in this case. They're sequenced. I can get back to the front relatively quickly, but I got to go through the whole circle to get there. So a circular linked list. I can't just cut across from 3 o'clock to 9 o'clock. I got to go through 4, 5, 6, 7, 8 before I get to 9. Same thing happens here. Now, if I am a doubly linked list, I've got the head and the rear again, but now I put in a second link going backwards. So I got a forward link and I got a backward link. So this way I can go front, back, forward, back. I can go a lot of different directions here, but of course you've got multiple links to worry about. So as you're deleting one, you just got to be careful as to what are you deleting and what am I modifying. But it gives you a lot of flexibility as far as which direction in this linked list you're going. So just keep that in mind. So doubly linked list is very useful. 2 sets of pointers, forward and back, lets you go any direction. Unlike the circular linked list, there's still, I can get to a lot of different information sources, but I can only go one direction. I can't go from 95 to 10. But this one I can go 95 to 10, or I can go 95, Now, granted, if you could you have done it a doubly linked circular list? Sure. What would that have given you? That would have given you one more set of pointers, which then would have gotten you back to the front of the list faster than before. So different options. Now on a doubly linked list, inserting, like you said, you're dealing with 2 different nodes. So just keep that in mind. So you got to keep the head and the rear node, because here you start with nothing. Inserting this, in this case, what? With only one from a null list, the head and the rear are identical. So that's one thing you got to make sure you understand. Now, if I'm inserting into an existing list, now I've got to modify several different pointers. That says here, I'm going to put this in place. So I got my head and rear pointer, my backward pointer. When I'm inserting this one in, basically what do I have to do? One, you're traversing in here to find where it fits into sequence. And now I'm going to modify the backward pointer to the 20, the forward pointer to the 40, and nothing else really changes. Now, if you change it to the rear, what would you think would change? Yeah, you'd have to modify the backward pointer, and the forward pointer would go where? Pretty much nowhere. But it would start with a null, so just making sure you insert p new would have to be added to the forward pointer. So here's the algorithm for inserting into a doubly linked list. Your preconditions, you got the list, you got the data in you want to insert. And what are you returning out? I'm returning the data inserted in sequence. That is crucial. Of course, there are a couple of different failure options. In this case, we're giving you 3. 1, it failed, there wasn't enough memory. Return a 1 if it was successful. And 2, if it failed, it says, hey, I want to double check, is it a duplicate? Because based on your application, you may want to do that comparison and say, oh, if this already exists in a list, I don't need to add it. So, so the first thing you're doing, hey, can I check if the list is full. So check the full as list, call the same routine we just discussed, and return 0 because it failed. Probably never run into that condition, but you never know. Now, if it's successful, list is not full, now I can double check where I'm going to insert this. So I'm going to do my search list, see if it's not found, then I can allocate. Now, if it was found, what were you going to do? I was going to return failure. So here you allocate this new node, move the data into the new node, making sure that, is it the first node? It's in the middle of the list. Make sure you're not at the end of the list. So otherwise, back here's where your key already exists. So just keep in mind, a little bit of what, let's go ahead now. Doubly linked list, the same thing before. Now I've got to just pay attention to the forward and backward pointers. You found your item. You got to change the forward pointer to the one you're deleting's forward. You guys should change what? You got to change your previous pointer to the one you're deleting's forward before you can move on. So here's just the algorithm. I'll let you go through that algorithm. But I think this picture should help you. It's once you found the item you want to delete, this forward pointer has got to be moved to, the next pointer here. And once you've done that, because what I have to do, I can also change the backward pointer here to this previous, the back link here. So you're basically copying both links of the one you're deleting to the next items, either before or after the item that's being deleted. I did assign you, I think, problem 16. So just so you have a picture in your head as far as what we're talking about, pay attention to this one. This would be a good one to have. Hopefully this helps to kind of shape out your linked list that you had in C++ and Java. If not, if it's more confusing, let me know. Talk to you later. Bye-bye.